So for applied problem 1, we're using this formula, which you have probably seen in a previous course, but I'm going to demonstrate with different numbers so that you can have something to follow along with. What is the amount A after investing $2,000 at 13% interest compounded monthly for 10 years? So for this problem, compounded monthly means K equals 12. That's the number of times we compound per year. E equals 10, because that's the time period. P equals 2,000, because that's the starting amount. And R equals 0.13, because that's the decimal form of the percentage. So you're really just plugging all those numbers where they're supposed to go in the formula. Okay, so we're going to be plugging in 2,000. Gotta make my font way smaller though. 2,000, and then it's 1 plus 0.13 divided by 12. 0.13 is my R, and K is 12. And then we're going to raise that to the power of 12 times 10, because I said 10 years. So you can run that through a calculator. If you don't have one, you can go to desmos.com/scientific. But I can do it with this calculator right here. 0.13 divided by 12. I'm doing the parentheses first. And then the exponent is 120. So I'm going to raise that to the power of 120. Then times 2,000. So the amount you'll have is $7,287.47 after this time period. And for part B, we're doing the same thing, except K equals 365. Okay, because the K stands for the number of times you compound per year. And if you're compounding daily, that means you're compounding 365 days a year instead of 12 times a year. There's what the formula looks like when we plug in 365. 13 divided by 365 plus 1. And that's a power of 3650, then times 2,000. And so even though we've started with the same amount, we have the same interest, because we're compounding more times per year, there's more time to put interest back into our total amount of money. And so we accumulate a little bit more money in terms of part B. Okay, so I can't tell you what to say for C. This is your guess. What would happen to the amount A if interest was compounded every second? So we went from 12 times a year to 365 times a year, and you can see that the dollars went up. So what happen if instead of doing 365 times a year, the number, if we compound every second, so it's 365 days in a year, 24 hours in every day, 60 minutes in every hour, 60 seconds in every minute. That would be K. You don't have to calculate it, okay? You can just tell us what happens. Does it go up or down, and why? And D, what would happen to the amount if interest is compounded an infinite amount of times per year? So this is, again, a place where you can make a guess. So that's it for there. You can write your own guess there. And when we say limit notation for part E, that means you need to be writing this somewhere. And it might be as easy as you're thinking. Okay, the limit as x goes to infinity. That's one we see a lot in our textbook. It looks something like this. And then you would put your function in here. It doesn't matter how many letters you have. Okay, you could have a bunch of letters in here. Limit notation just means you're saying the limit as something approaches some other value. So write the limit notation for this is your function. So this is what should go in the parentheses here. It's supposed to be the limit as k approaches infinity. Okay. And just conceptually, why we're doing this is because up here we just saw that if a bank compounds monthly instead of, if a bank compounds daily instead of monthly, we get more money. So a customer should be saying, hey, if you're going to give me interest, I want you to compound as many times as you can, right? So that's what we're doing, is we're taking the limit as k approaches infinity, compounding an infinite amount of times per year. And then for part F, we're going to approximate that limit because that's too hard for where we are in calculus right now. Later on in calculus, maybe you could evaluate that limit, but we're going to approximate the limit. So plug in 1,000,000 in for K into the formula. So repeat parts A and B, except instead of using the other K's, use 1,000,000 in for K. And that means you've really got to carry out your decimals on those calculators. So use the scientific calculator. and then analyze your prediction in part D. Okay, so part G, this is where you got to do just a little bit of research. It's a special limit in mathematics, and there's one letter. You know, like pi is a special Greek letter we use in mathematics. So there's another letter that we use to represent this limit. Okay, so do a little bit of research and some keywords. I think I say here. Yeah, I say compound, infinitely, continuous. Use those words. You should be able to find out the special letter that represents the exponential change, so the compounding infinitely amount of times per year.